Hello dear viewers, welcome to my tutorial video. In this session, I am going to show you how you can measure rotational speed and detect direction of motor using high-speed counter of Siemens S7-1200 PLC. A rotary encoder, attached with the shaft of a motor, generates pulse signals with respect to motor speed, and these signals will be applied to the high-speed input of S7-1200 PLC. Configuring PLC high-speed counter and using PLC simple ladder logic, the pulse signal of encoder then will be converted to rotational speed in RPM, and also it be possible to detect direction of motor rotation. When we will come to finish this project, we will run an induction motor at various speeds in both forward and reverse direction. Then high-speed counter will measure motor rotational speed in RPM and detect direction of rotation that will be visible from the WinCC SCADA interface. High-speed counter HSC is a specialized hardware component integrated into compact-type PLC like S7-1200, or this can be available as a separate high-speed counter module for rack or modular-type PLC like S7-300 or S7-1500. These high-speed counters have been designed to count input pulses or events at a speed much faster than normal counter. Normally, high-speed counter is used for measuring frequency or period measurement, which can then be used for detecting the speed and direction of rotary motion, velocity of conveyor belt, track position, measure the length of an object. Generally, high-speed counter has different operating phases. For counting pulses in upward or downward direction, the operating phase of counter will be single phase with internal or external direction control. Other high-speed counter operating phases are two-phase, AB phase quadrature counting, and AB counter fourfold. For detecting the speed and direction of rotation, a rotary encoder has been attached to the shaft of motor, and two different output channels of this encoder will be used to get pulse signal for PLC. In this case, PLC high-speed counter will be configured as AB phase quadrature mode. In AB phase quadrature counting mode, two different pulse signals from rotary encoder will be applied to PLC high-speed counter inputs, where these two pulse signals will be 90-degree out of phase to determine both speed and direction of rotation. By comparing the state of these pulse signals, the high-speed counter can determine the direction of rotation. If A leads B, the high-speed counter counts in the upward direction and the rotation is in one direction. If B leads A, the counter will count in downward direction and the rotation is in the other direction. In this way, the PLC high-speed counter function not only measures speed, it also can detect the direction of rotation. For generating pulses with respect to motor rotation, I have selected an incremental rotary encoder which comes from Autonix E40 series that have encoders of different sizes and features. The selected encoder model produces 1024 pulses per revolution of encoder shaft. Take a look at the details of its connection terminals. For generating pulses, this encoder has three output phase, A, B, and Z, where for connection with the PLC input, these three phases have three connection terminals of black, white, and orange colors. Among the output phases, the phase A and B provide pulse trains corresponding to shaft rotation, which are offset by 90 degrees, and the other phase, Z, provides one pulse for each complete revolution at a specific position, which is used to set a reference point. The supply voltage for this encoder is 24-volt DC. And for supplying this voltage, this encoder has brown color terminal wire for connection with the positive terminal of power supply and blue color terminal wire for connection with the negative terminal of power supply. The encoder has one more terminal for shielded wire, which will be used for grounding the metal body of the encoder. Now take a look at the encoder output circuit diagram for understanding the connection procedure of encoder output with the PLC high-speed counter input. The encoder offers different types of output circuit. The encoder model selected for this project provides a totem pole output where both open collector type output and voltage type output can be used for encoder connection with the PLC. In this project, for encoder output connection with the PLC high-speed counter input, we will use the voltage type encoder output. For hardware connection of encoder output with the PLC, take a 24-volt DC power supply to power up the rotary encoder. Make a connection of positive terminal of power supply with the positive wire of encoder and negative terminal of power supply with the negative wire of encoder. To receive encoder output signal, PLC digital input I0.0 and I0.1 will be configured as high-speed counter input using TIA Portal software device configuration. Now for encoder output connection, connect encoder output terminal of channel A with PLC digital input I0.0 and terminal of channel B with the PLC another digital input I0.1. Connect common terminal of PLC digital input with the negative terminal of power supply. This will complete the hardware connection of encoder with the PLC.
Now proceed to configure the high-speed counter and PLC programming using the TIA Portal software. First, open the TIA Portal software and create a new project for S7-1200 1214 AC-DC relay. The project has been created for S7-1200 PLC, and we are now on the PLC hardware configuration window. We can proceed by first configuring the digital inputs of PLC as high-speed counter input so that the PLC digital input can process encoder pulse signal at higher speed. Go for digital input channels of this PLC As we are using high-speed counter as AB counter, it requires 2 digital input channels for processing encoder 2 channels pulse output. So we have to configure 2 digital input channels as high-speed counter inputs. Select the Channel 0 digital input under General tab. On the right side, you will get an option for setting input filter. Set the time for input filter 6.4 microsecond. Select the second channel. On the right side, set the time for input filter as 6.4 microsecond. Now the digital input channel 0 and channel 1 are ready to process encoder pulses at higher speed. In the next step, go for high-speed counter to configure it. There are 6 high-speed counters for this PLC, and for speed measuring, we will configure high-speed counter number 1. Expand the menus for high-speed counter number 1. Here you will find a number of settings that has to be done for configuring high-speed counter. Click on the General tab. On the right side, put tick mark on the checkbox for Enable this high-speed counter. Go for Function tab. On the right side, set the type of counting as frequency for measuring speed. Set the operating phase as AB counter for detecting the rotation direction. Click on the menu for hardware input. As operating phase has been set to AB counter, on the right side you will get the option for selecting input address for 2 digital inputs. As we have configured digital input channel 0 and channel 1 as high-speed counter inputs, the digital input address will be I0.0 and I0.1 that have been already set by default. If you use another digital input channels, provide their respective input address for hardware input setting. Go for the last tab, Counter I/O Address. On the right side, you have to set register address where high-speed counter value will be stored. Keep default setting ID 1000 as register address for high-speed counter.
We have come to finish configuring our desired high-speed counter. Now go to Project Tree and open the window for ladder programming. In this window, we will make simple ladder logic to get the motor speed in RPM and detect direction of rotation. Finally, this is the ladder program to get the motor rotational speed and detect direction of motor rotation. When the motor will be run, the PLC high-speed counter will count the number of encoder pulses generated per second, and this count value will be stored in the high-speed counter address ID 1000. The data type for this count value is signed double integer. But we want to get the speed data precisely in the format of real or floating point number. So, in the first network, integer value of ID 1000 has been converted to real type value using move and convert instruction. This converted real type counter value will be found from the memory address MD120. As the encoder produces 1024 pulse per rotation, so divide the real type count value of MD120 by 1024.0 to get the count value in revolution per second. Finally, multiply this value by 60.0 to get the count value in revolution per minute that will be stored in memory address MD200. If the motor rotates in reverse direction, MD200 will hold negative value. But it will better option if we take the motor speed value in non-negative number, whether motor rotates in forward or reverse direction. So in the third network, this has been done using absolute value function to get the non-negative value of motor speed through register address MD220. So for SCADA-based operation, value of MD220 will be used for speed monitoring. Now, to get the indication of rotation direction, ladder logic with comparator function of these two networks has been used where tag value of MD200 will be compared with 0. When the motor rotates in forward direction, the tag of MD200 gets positive value, and comparator function will energize single-bit register M10.2, which means that motor is rotating forward direction. When the motor rotates in reverse direction, the tag of MD200 gets negative value, and comparator function will energize single-bit register M10.0, which means that motor is rotating in the reverse direction. The ladder program is almost done. Now compile and download this ladder program to PLC. Ladder program has been transferred to PLC, and we are ready to perform motor operation to get motor speed and direction in the ladder program. Turn on the monitoring option to observe the status of running program and get the different tag values. Motor has started to run in the forward direction. We are now getting speed value in revolution per minute through the PLC tag speed in RPM. The single-bit register M10.2 is energized now, which means the motor is rotating forward direction. Now change the motor speed and observe the motor speed from the ladder program. The PLC tag for MD220 is changing its value. Stop the motor and again run the motor in the reverse direction. Note that single-bit register M10.0 is energized now, which means the motor is running in the reverse direction. To observe the motor speed and monitor direction of rotation from SCADA interface, a WinCC SCADA interface has been developed based on the PLC tags of ladder logic. Now we will perform motor operations same as before and observe the motor speed and direction of rotation from WinCC SCADA interface. We have reached almost at the end of this video. If you find this video helpful for you, please like, share, and make comments on this video, and don't forget to subscribe this channel.